Hello viewers, welcome back. Welcome back to our circles class. So, in the last class we discussed about that the central form of a circle, and when the equation of circle is given, how to get the center and the radius of a circle. Okay. So, let us see. So, what is the central form of a circle? I mean, when the center and the radius is given, this is x minus h whole square plus y minus k whole square equals to r square. In that case, the center is, see, let us take h comma k and radius is r, okay, which is called central form. When the center and the radius is given, then we will get the equation of a circle, okay, of course. And the general form of a circle, what is the general form of a circle? General form of a circle, which is x square plus y square plus 2gx plus 2fy plus c equals to 0. In that case, the center is minus g and minus f, and radius is root of g square plus f square minus c. Okay. From the last video we discussed about this case. Okay. And we discussed one more thing also. Suppose that when the second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0, general form of a second degree equation. When it becomes a circle, the conditions of those, the first condition is coefficient of x square equals to coefficient of y square. That means, a equals to b, coefficient of x square equals to coefficient of y square. And the second condition is, so coefficient of xy, so is equals to 0, that means h is equals to 0. Okay. Yes. So, then, so by taking these two conditions, then what it becomes? So, a of x square plus y square, right or not? So, a equals to b, a of x square plus y square plus 2gx plus 2fy plus c equals to 0. Okay. Yes, transforming it to that form, which is x square plus y square plus 2g by a of x plus 2f by a of y plus c by a equals to 0. In that case, what is the center? Okay, center minus of x quotient, half of that one, and minus of y quotient, in that case half of that one. So, okay, here center is minus g by a minus f by a. Okay, then what is radius? Radius is root of g square, that is g square by a square plus f square by a square minus c, constant, what is the constant? Minus c by a, right or not? So, in that case, so you can get the condition is like this. So, which is root of g square plus f square minus ac by modulus of a. The value under square root, this must be greater than or equals to 0. Okay. So, these are all the conditions, when the second degree equation, general form of a second degree equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 represents a circle. Coefficient of x square is equals to coefficient of y square, coefficient of xy is equals to 0, I mean h is equals to 0, and the radius, this condition, root of g square plus f square minus c should be greater than or equals to 0. Okay. So, from the last video we discussed about this one. Okay. So, let us continue that different form of a circle. Okay. Yes, let us see. Yes, the next form of a circle is the diametric form. What is the diametric form? Okay. So, what is the equation of a circle? What is the equation of a circle? So, whose ends of diameter are given? So, let us see, this is the center of the circle. So, C and A, the point is x1 y1, the point B is x2 y2. The 2 points A and B are the ends of the diameter. If AB is the diameter, then what is the equation of a circle? Okay. Yes, if AB is the diameter, these two equal parts are called semicircle, and we know that angle in semicircle, let us take any point, locus point x comma y. So, what is the angle in semicircle is 90 degrees, am I right or not? So, let us take any point in that semicircle, angle in semicircle is 90 degrees, come on. So, here AP is perpendicular to, AP is perpendicular to PB. So, two lines are perpendicular. So, product of these slopes is minus 1, come on, this can be written as So, y minus y1 by x minus x1. So, into PB, what is the slope of PB? Y minus y2 by x minus x2 is equals to minus 1. Okay. By simplifying this one, we will get the equation x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0, which is the equation of the circle whose ends of diameter are given. Yes, come again. So, whose ends of diameter are a x1 y1 b x2 y2, then what is the equation of a circle? So, x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. This is the equation of a circle, that is called diametric form. That means, whose ends of diameters are given, we are going to finding the equation of a circle. Okay, not? Yeah. So, let us see that one more thing. Okay. So, the next thing is the concentric circles. So, what are concentric circles? Okay. Just see this one. So, two circles are said to be concentric circles. They have same center. Okay. So, they have same center. So, with different radii. Okay. Then the two circles are said to be, yes, these two are the two circles, right. Let us take this is C1 and C2. Both the circles having the center is C, okay, but having the different radii. Let us say this is R1 and this is R2. Okay. So, here radii are different. Then the two circles are said to be concentric circles if they have same center with different radii. Okay. So, generally we can write this one. Suppose x square plus y square plus 2gx plus 2fy plus c is equals to 0 is the one of the circles, then its a concentric circle be in the form of x square plus y square plus 2gx plus 2fy plus k is equals to 0. Please observe this one. So, what is the concentric circle to the given circle is they have same center, that means they have the x and y quotients are the same and the difference is only in their constants, then only we will get that different radii. Then we can say the two circles are said to be concentric circles. Yes, come on, once observe this one. So, where they have that the difference between the two concentric circles is only they have the different constants. Okay, not? So, that is about that the concentric circles. Okay, not? Come on, make a note, the students. We will move to that the next concept. So, here onwards throughout the chapter we are going to using the notations. What are the notations? Okay. So, let S equals to x square plus y square plus 2gx plus 2fy plus c. Okay. So, that means S is equals to 0. S is equals to 0 means x square plus y square plus 2gx plus 2fy plus c is equals to 0 represents a circle. Okay, represents a circle. So, without writing the total thing, simply we can write S is equals to 0. S means our general form of a circle, x square y square 2gx 2fy plus c. Okay. Similarly, S1 is x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c. Yes, this is about S1. S2 x2 plus y2 plus g of x plus x2 plus f of y plus y2 plus c. Okay. So, S12 x1 x2 plus y1 y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c, and S11 x1 square plus y1 square plus this is 2g x1 2f y1 plus c. Okay. So, this is about the notations. So, throughout the chapter we are going to use without writing the total expansion, simply we can write S or S1, S2 or S12 or S11. Okay, right? Yes, come on, students, make a note. Okay, this will be useful. So, in the next topic. Okay, yes, let us see. Yeah. So, the next concept is the position of a point with respect to the circle S is equals to 0. S means our general form of a circle x square y square 2gx plus 2ay plus c is equals to 0. So, for that the center of the circle is minus g and minus f, and the radius is root of g square plus f square minus c. Yes. So, for one circle, okay, so they are going to giving that circle S is equals to 0, center is minus g and minus f. This is the center of the circle. Yes. Now, I am going to giving the point P, x1 and y1. Okay, then. Yeah, what is the position of a point with respect to circle? It may be outside of the circle, it may be inside of the circle, it may be on the circle. Okay. So, now we are going to get the condition. Yes, what is this one? First of all, please find out the distance between CP. Okay. So, which is x1 plus g whole square, right, and it is y1 plus f whole square. Okay, then. Yeah, and so please find out this one. Okay, here he will get one condition. So, please compare CP and radius. So, here clearly we will get this one. This is CP, the distance between the 2 points, and it is only radius. And clearly you can say, if CP distance is equals to r, then the point lies on the circle, right or not? If the CP distance is greater than r, the point lies outside. This CP distance is greater than r, clearly you can say the point P lies outside. If these two distances are equal, if CP is equals to r, the point lies on the circle, right or not? If the CP distance is less than r, okay, then. So, clearly what we are comparing, the distance between CP and the radius r. Okay, then. Yes, come on. So, please find out CP square minus r square value, what it will be. Suppose if CP is equals to r, what do you say now? CP is equals to r, then we can say the point P lies on the circle. So, that means the CP square minus r square value is equals to 0. That means from this one I can write like this. So, what is the CP square? Yes, by simplifying this one, what do you get? CP square value, it is x1 square plus y1 square, yes, plus 2gx1 plus 2fy1, 2gx1 plus 2fy1 plus g square plus f square. This is the CP square value, minus r square, yes, it is minus g square minus f square plus c. Okay, it is equals to 0, g square plus f square get cancelled. What do you say? This one is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Just now I explained that one notation, the notation is known as S11, right? Another S11 is equals to 0. When this condition, if CP is equals to R, CP is equals to R means the distance between CP and R equal, then what do you say? The point P lies on the circle. So, P lies on the circle, S is equals to 0, right? Another. So, here S11 is greater than 0. S11, that means CP greater than R, CP greater than radius, right or not? That means P lies outside to the circle, S is equals to 0. Similarly, S11 is less than 0, then the point P lies inside. Okay, not? So, like this we can find the position of a point with respect to circle. Okay, totally depend upon what is that value. S11 means x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is 0, lies on the circle, greater than 0 outside of the circle, less than 0 inside of the circle. Okay, students. So, come on, make a note. Yeah. So, the next concept is very important, the shortest and greatest distance of a point with respect to a circle. So, here I am going to giving a circle S equals to 0, right. So, center is minus 3 and minus f. Now, I am going to giving a point P. So, it is x1, y1, a point P. So, what is the shortest distance and the greatest distance? So, of a point P, okay, of a point P with respect to the circle S is equals to 0. Right or not? Yes, let us see. So, come on, joining this one, okay, and I think this is your radius. It is your radius or not? Okay, then let us take this is the some point M, okay, and this is some point N joining this one. Yes, so from that diagram it is very clearly what you say, what is the shortest distance of a point to the circle? I think this will be the shortest distance, am I right or not? This will be the shortest distance of a point to the circle, right or not? So here can I write like this one, shortest distance. Yes, so shortest distance is, it is PM, is the shortest distance of a point to the circle. So how can you get the PM? It is CP minus R, the distance between C to P minus R. So it is modulus of Cp minus R is the shortest distance of a point to the circle. Cp, what is Cp? The distance between center to the given point minus R, you will get this, this will be the shortest distance. Okay, and what is the greatest distance? Maximum distance. Okay, so I think Pn will be the greatest distance, is it right or not? P to N is the greatest distance, which is Pn. Yes, how can you get the Pn distance? Pn, this can be written as a Cp distance plus this is also radius, am I right or not? Okay, Cp plus R. So it is Cp plus R is the maximum distance of a point with respect to the circle. Please observe this one, shortest distance is Cp minus R. So greatest distance is the Cp plus R. Okay, yes, and from this one we will get one more concept, very important thing is, so find the point on the circle, please listen, find the point on the circle which is nearer to the given circle, which is nearer to that the given point. Okay, that means they are asking about the point P. So the point M, so it is a point which is nearer to the point P and on the circle S is equals to 0. They ask the question is like this, all of you listen. Find the point on the circle. So which type of point this is, which is nearer to the given point P. So what is P? First of all, this is the given point, right or not? Now I am going to finding the point which is nearer to the P, that is lies on the circle. Okay, yes, how can you say this one is M is the point which is nearer to the given point and which is on the circle. How can you get this one? Okay, the point M which divides Cp in the ratio of, okay, in the ratio of, so how can you write this one? So this is the point P which divides Cp in the ratio of Cp minus R is to R internally. Okay, not? So this is which divides Cp, am I right? Which divides Cp in the ratio of Cp minus R is to R internally. So by using this section formula I can get the point P, right or not? The point P which divides Cp in the ratio of Cp minus R is to R internally, then you will get the point M. Similarly, yes, similarly, what is the point P on the circle, okay, which is maximum distance to the point P. So in that case, same like this, you can say the point N which is very far to the given point, which divides Cp in the ratio of Cp plus R is to R externally. Okay, like this we will get the point. Okay, very important concept, greatest distance and shortest distance of a point, and finding the point on the circle which is nearer to the given point, which is greatest distance to the given point. Okay, so very important concepts. Come on, make a note. Yes, now we are going to discussing about that equation of a circle. Yes, equation of a circle. Let us see of those. So one of the very important thing, let S is equals to 0 is any circle. Yes, and the line L is equals to 0 which intersect the circle at 2 points A and B. Yes, S is equals to 0 be the given circle and the line L is equals to 0 which intersect the circle at the 2 points A and B. Now what is the equation of a circle which is passing through the points A, B? So there is a circle, so which is passing through the point of intersection of the given circle S is equals to 0 and L is equals to 0 is must be in the form of S plus lambda L equals to 0. Yes, what is this one? Equation of a circle. Yes, what is this dotted circle condition is which is passing through the point of intersection of a circle and a line. Okay, this must be in the form of S plus lambda L equals to 0, very important model. Okay, yes, and one more thing also same like this. So, one circle S equals to 0 is given, okay, and the line, yes, the point P. Yes, then what is the equation of a circle which touches the line at the given point P? It is also in the form of S plus lambda L equals to 0, very important model. Okay, right. Equation of a circle which intersects the circle at 2 points A and B, this must be in the form of S plus lambda L is equals to 0. Okay. Now, we can discuss some different cases. So, what is the equation of a circle which is passing through the given 3 points? Okay. Yes, let us see what are the conditions. So, here we are going to discussing about the equation of the circle which is passing through the given 3 points, 3 non-collinear points. Okay. Now, let me explain the different cases. Okay. Suppose the points ABC, the points ABC forms an right angle triangle. Suppose if they form right angle triangle, right, like this. Suppose this is the point A, this is the point B, this is the point C. Okay. Equation of a circle which is passing through the points ABC, if the points ABC form a right angle triangle. Yes, already we know this one. If ABC is a right angle triangle, the circumcenter lies on the midpoint of hypotenuse. Am I right or not? So, M is the midpoint. So, which is the circumcenter, right or not? Circumcenter. So, denoted by S. We will get this one. Okay, then. So, after getting that circumcenter, this will be that circumradius, right or not? This which is the half of the hypotenuse. Then we will get that one center and the radius. Then if the center and radius is given, we know that the form is the central form of a circle, x minus h whole square plus y minus k whole square is equals to r square, right or not? When it is, we are going to say if the 3 points forming a right angle triangle, then the circumcenter is the midpoint of hypotenuse and circumradius is the half of the hypotenuse length. Okay, then like this we will get the circle. Suppose if the 3 points forming a right angle triangle. Okay. So, and one more thing, we know this easily. If the 3 points forming an equilateral triangle, suppose the second case is the if AB equals to BC equals to AC, that means they may form the equilateral triangle. Okay, they may form the equilateral triangle. Then, so the circle which is passing through the 3 points. Okay, so it is very simple finding that in equilateral triangle the circumcenter, orthocenter, okay, and the centroid coincides. The S is equals to G, right or not? So we will get this one. What is G? G is nothing but centroid. So simply it is enough to find out the centroids, then we will get the circumcenter. After getting the circumcenter, we can find this one. So this is SA is equals to SB is equals to SC, which is a radius. Like this, we will get the radius. You can find that from the circumcenter to any point. Then we will get that radius one. So after getting the center and the radius, and again we are going to use that your central form. Okay, net. This is one more way. Yes. Now, and if the 3 points they are not forming a right angle triangle, they are not equilateral triangle. In that case, what we are going to do? Let us say I am going to explaining this one. Yes, first of all, please find out the circle. Yes, consider a circle S is equals to 0. Consider a circle S is equals to 0 whose ends of diameter and are A and B. Suppose we are going to find the equation of a circle whose ends of diameter A and B. Actually, this is not a required circle. So, A, B are the ends of the diameter. Like, let us take this one. Okay. So, already we know this one. What are the equation of a circle whose ends of diameter? Formula is the x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Like this, by using this formula we are going to get the equation of a circle, right or not, whose ends of the diameter. Yeah, and find out the equation of a circle, find out the equation of a circle whose ends of diameter, that is okay, and find the equation of a line. So, find the equation of a line AB is equals to 0. Okay, now, yes, so please better to find that equation of a line L is equals to 0 also. Please find out this one, the line equation L is equals to 0 also. Okay, yes. Now, you got that equation of a circle. This is the equation of a circle, S is equals to 0. Then after, what you are going to find? The equation of a line L is equals to 0. Right. Now, we are going to find out one equation of a required circle. So, let us consider this one. So, equation of a required circle, this is the required circle, which is passing through point of intersection of S is equals to 0 and the line L is equals to 0. Just now I explained, which is in the form of S plus lambda L is equals to 0. This is required circle. All of you please. Yes. So, what is that? This is the required circle which is passing through our assumption circle S is equals to 0 and the line L is equals to 0. Okay, they are intersecting at the point P. From that point the required circle is passing. So, that must be in the form of S plus lambda L is equals to 0. Yes. Then how to get the lambda value? Okay, already we know this one, equation of required circle passing to the points A, B, C. Yes, this A, B and substitute the point C. Yes, the required circle is passing to the point C also. Now, the point C, to get that lambda value, substitute the point C in this equation, you will get lambda value. That is the one of the easy way to find the equation of a circle. Yes, first finding this one, a circle S is equals to 0 whose ends of diameter are any 2 points A and B. By using the formula, we will get this one. And finding the equation of a line L is equals to 0. Then the required circle is in the form of S plus lambda L is equals to 0. Yes, and lambda value, how to get the lambda value? Taking the point C, okay, and substituting in this equation, then we will get the equation of a circle. Okay. So, already I explained about this one in the previous video, particularly once you check my video, you will get this one, equation of a circle, okay, which is passing through the given 3 points. Okay, not? Yes, come on, check that video, you will get that very clarity. Yes. So, that is very important concept, equation of a circle passing through 3 non-collinear points, and I discussed about the concyclic points also. Yes, come on, make a note. Yeah, and one more important thing is the equation of a circumcircle of a triangle ABC. In that case, whose sides are given, the equation of the side AB is L1 is equals to 0 and the equation of the side AB. Okay, equation of this side BC is equation L2 is equals to 0, equation of side AC is L3 equals to 0. Okay. So, now here they are not giving the vertices, equation of the circumcircle of a triangle ABC whose equations of the sides are given. So, the common thing is the finding the point of intersections. Okay, I mean solving the 3 equations, you are going to get the points A, B, C. Then after that, as usually we are going to following the process, equation of circle passing through 3 points. Okay, right? We can follow that method also, or it will be very lengthy method. In that case, we are going to use one more method, that is, okay, yes, combining the equations. So, combining the equations, then we are going to applying that equation of a circle. Yes. So, how it will be combining the equations, right? Let us see. So, this one equation of a circle. Okay. So, which is passing through that the point of intersection of L1 is equals to 0, L2 is equals to 0, L3 is equals to 0 is L1 into L2 plus some constant into L2 into L3 plus another constant into L3 into L1 is equals to 0. Yes. So, what is this? L1 into L2 plus one constant into L2 into L3, I mean combining the equations, plus another constant into L3 into L1 equals to 0. Yes, totally we will get that a second degree equation, right? So, for that second degree equation, suppose if it represents a circle, so of that we are going to use these conditions. Okay, it represents a circle. In that case, coefficient of x square is equals to coefficient of y square. Why? Because it is a circle for the triangle ABC. Yes, so any second degree equation represents a circle. These are all our conditions. Coefficient of x square is equals to coefficient of y square, and the second thing is the coefficient of xy is equals to 0. Yes, two conditions. By applying the two conditions, you are going to get this the unknown variables lambda 1 and lambda 2. Right? So, very important thing. So, without finding this from the vertices and without using that the long method, so this will be very easy. Right or not? So, L1 into L2 plus some constant into L2 into L3 plus another constant into L3 into L1 is equal to 0. We will get a second degree equation. To get that unknown variables, please use the conditions. Okay. So, coefficient of x square is equals to coefficient of y square and the coefficient of xy is equals to 0. Okay, students, come on, make a note. Yeah. So, very important concept in the objective point of view. So, if the lines a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals 0 cuts the coordinate axis at concyclic points, then this will be the condition a1 a2 equals to b1 b2, and we are going to find the equation of circle also. Yes, please observe this one. L1 is equals to 0 and L2 is equals to 0. They are the two lines which intersect the coordinate axis. So, the first line L1 is equals to 0 intersect that x axis and y axis at the 2 points A and C, and the second line is L2 equals 0 which intersect the coordinate axis at B and D. Right or not? Okay. And what about the points are? Concyclic points. What is the meaning of concyclic points? From those points the circle is passing. Right or not? So, if the 3 or more points are lies on a circle, then the points are said to be concyclic points. Yes. So, understood that if the two lines are intersecting the coordinate axis A, C and B, D, two lines L1 and L2. Suppose if the 4 points are concyclic, that means if the circle, any circle is passing through that 4 points, then what are the conditions and what is the equation of a circle? Yes, now I am going to finding the equation of a circle. Yes, so equation of a circle is a1x plus b1y plus c1 into a2x plus b2y plus c2 plus some lambda of xy equals to 0. So, what is that equation of a circle? Combining the two equations L1 into L2 plus lambda xy is equals to 0. Yes, that is the equation of a circle. Yes, if it represents a circle, yes, please apply the conditions. Already we know very clearly. Coefficient of x square equals to coefficient of y square. Yes, come on. What is the coefficient of x square? So, by multiplying these two, you will get that one x square term. What is coefficient of x square? A1, A2 is equals to, what is the coefficient of y square? I think this will be that y square term. What is the quotient is b1 into b2. Yes, that is it. Very important condition. A1, A2 equals to b1, b2. Yes, when we are going to use this condition, if these two lines intersect the coordinate axis at concyclic points, then what is your condition? A1, A2 is equals to b1, b2. Then how to get that equation also? I mean, how to get the lambda value also? So, in that case simply you are going to use coefficient of xy is equals to 0. So, what is coefficient of xy? It is a1 b2, right, a1 b2 plus a2 b1, right or not, a2 and b1, coefficient of xy, and coefficient of xy is plus lambda equals to 0. Yes, and what is lambda value? Minus of a1 b2 plus a2 b1, right or not. So, after getting the lambda value, substituting here, we will get that equation of a circle, which is L1 into L2 plus what is lambda value? Minus of a1 b2 plus a2 b1 of xy is equals to 0. Okay. So, that is about that equation of a circle which is passing through that point of intersection of L1 is equals to 0 and L2 is equals to 0. Okay, right. So, very important concept. Come on students, make a note. Yeah. Okay students, that is about the today class. Okay. So, we will continue that very important topic, a tangent and a normal to a circle. So, for the next coming video. Okay. So, please stay tuned to my channel. Okay. So, be ready for that next video. Until then, bye bye.